This is the reassessment for circular motion, and basically it's asking what the tension on the rope is if you have two masses tied together and tied to a point in the center of a circle being spun. And you see, first off, I just wrote down what I knew. I knew that two blocks are in two different positions. Pretty obvious, but drew a little picture of it, and wrote down what I knew. I knew that the mass of the first block is 0.05 kilograms, the mass of the second block is 0.03, and the radius of the little circle is 0.4 meters, and the radius of the bigger one is 0.75. And I just went ahead and figured out what omega was in radians, because you have to do that anyway. It's just a little easy math right there. And then went ahead and saw for the on the angular speed of it. My bad, I was looking at the wrong thing. I was looking for the angular speed in this one. So you got the formula written down: AR equals V squared over R, or V equals RW. And you solve it out. One R cancels on the bottom, one cancels on the top. That's how you get the RW. And then as far as that goes, you just fill in what you know. After you find omega, you know the radians, and you know the mass of the block, and it ends up giving you FR of 2. It's 2 newtons. And then you just do the same thing again for the other block, but at the end of that, you add what you get from the first block to it. Ends up giving you 3.775 newtons, and that's the force. And oh, never mind. I was right the first time. Yes, I don't know what I was thinking. Yes, the tension of it is 3.775 newtons. That's what the tension is on it. Because the force, I was reading the question wrong or jumping ahead. It gave me the angular speed, and that's how you saw it for the radian. That's what omega is. Is 1.5 revolutions per second, and you use that, and you calculate it out and determine it into radians per second, and then you use the radians to find the tension. I don't know why I just got that thing all backwards, but that's what I was solving for, is the tension. That's what you get at the bottom right there.